purpose of the following video is to show you how to calculate z-scores in Excel. Now, just as always, make sure you have your Excel spreadsheet open and the directions in the Word document available so you can follow along and replicate what I do. Of course, you're welcome to pause the video at any time to perform any calculations or just to catch up. Now, the first step that we always do when opening a spreadsheet is we check our codebook and make sure that we understand how the variable was collected and how it's being measured. So if you're looking at your spreadsheet there, you'll see that we have two variables. We have one that's called status, which is satisfaction, and then we also have another variable called alcohol. Now, if we hover over the cell for satisfaction, we'll see that looks like it was rated on a 7-point scale here from very unsatisfied to very satisfied. Let's take a look at our codebook. Our codebook tells us exactly what was asked of our participants. In this case, it looks like we're going to be talking about clients. So if we were looking at our clients within our own clinic, and we were to ask all of our clients these two questions, then we would be looking at population data. So it looks like we're going to assume population data here. That'll be important later when it comes to getting our standard deviation. All right, when it comes to the satisfaction variable, it looks like we asked our clients, how satisfied are you with your current life situation? And then for the other variable, alcohol, we asked how much they spent on alcohol in a week. So we'll suppose just for a second that we are marriage family therapists and we're working with our clients and we want to know these two things, their current life satisfaction and their alcohol. And so we probably want to compare those two to each other just to see if one might impact or affect the other when it comes to our clients. All right, so now let's go back to our data. Now remember, the second thing that we need to do is we need to sort our data and push any empty cells to the bottom of the spreadsheet. And so we can already see that there's at least one empty cell up here where we had a client who didn't want to provide how much they spent on alcohol in a particular week. So we definitely need to push that one to the bottom. I'm only going to sort one of these columns right now. We'll sort the other column when it comes to getting transforms as well as getting z-scores. So let's go ahead and sort the satisfaction column, and we'll save the alcohol column for later. Now up to this point, you should know how to do the sorting. Just remember it's the icon up in the top ribbon, and then we can sort from smallest to largest or largest to smallest. I chose smallest to largest here. We can then scroll down and see, in this case, at least for satisfaction, doesn't look like there are any empty cells, but as we were scrolling, we saw at least one for alcohol, but we'll worry about that once we get to that alcohol variable. All right, so the next thing that we need to do, we need just to make sure that our data analysis tool pack is installed. And so we'll go up to our data tab. You can see for me it is there, but if it's not there for you, then you want to make sure that you install that. Just remember that the directions are linked in the lecture from last week when we talked about measures of central tendency and measures of variability. Now that we have checked our variable and ensured that the data analysis tool pack is installed, let's go ahead and go down to our directions here in the Word document. So the very first thing we need to do before getting z-scores, we need to make sure that we check the skewness of each of the variables, right? And so we want to make sure that our distribution is a normal distribution. If it's not, then we have to do transforms. So we're going to do some transforms along the way here today as well. Okay, so the steps to do it is we'll get our descriptive statistics, look at our skewness table, and also the skewness statistic, and compare the two to each other. So let's go up to data. We'll go to data analysis, and we'll do the satisfaction variable first, and then we'll come back to the alcohol variable and check that one as well. So we get our descriptive statistics, click OK, and again, you should know how to get this by now. We've done this several times. Input our data, in this case column B. We do have labels in the very first row of our data, so we'll check that box. We want the summary statistics, and then we want to put our output someplace in the data set. I'm definitely going to give myself some room here because I still need to calculate z-scores and probably need to do transforms. So I need at least 4 columns, 2 for transforms, 2 for z-scores. So I'm going to put my data here in column I. I'm going to want at least one space between my data and my table for my descriptive statistics. So I'm going to put an extra one here for H, and then I'm going to put my data, my output for descriptive statistics in column I. I'll go ahead and click OK, and there is my satisfaction variable. See, I have my mean, median, and mode for my measures of central tendency. I have my measures of variability, the standard deviation, variance, and range. But the thing I'm particularly interested in looking at here is this skewness statistic. So the skewness statistic here is a negative 0.87. So if I'm looking at my table, and if I have 79 observations, then I'm going to go to the end size that's closest to 79. And that gives me at 80. Right? And so for me to assume a normal distribution, I need my skewness statistics to fall between plus and minus 0.41, just like what we learned in the last module. In this case, we get a negative 0.87. That definitely is falling outside of my range of normality. It looks like when it comes to satisfaction that it is negatively skewed. So that means we're going to need to make a correction here. So if you remember from the last module, module number 1, that to correct for a negative skew, we're going to take our data to a power greater than 1. And usually a square will work. We usually start there, and then if it's too skewed, then we might increase the power or the exponent to try to correct for the data. All right, and so that's what we're going to want to do. So notice if the variable is skewed, we need to transform that variable. So we're going to create a new variable here in a new column. We'll give it a name. We'll put t in front of it just so that we know it's the transform. All right, and then we'll put in our transform in the cell, and we'll drag that transform down. And so notice here that we have a negative skew. So it says if negative, right, we're going to use a power greater than 1. So we're going to start off with a square, see how that works, and then we'll work from there. Once we transform that variable, of course, we need to go back and check for normality. So we're just going to double check, make sure it did the correction like it was supposed to. If not, then we'll have to do a stronger transform. All right, so let's go to our data here. Remember, the first thing we need to do, we need to create this new variable now that we know that it is, in this case, negatively skewed. I'm just going to put t underscore sat for satisfaction. So I'm just creating a new column. I'm giving it a label. It's going to be my transformed label. And then we're going to go to the cell right below it, and we're going to hit equals. We'll click on the cell that we wish to transform, right? And then we're going to put it to a power greater than 1. And so the power key in Excel is going to be this up arrow, which is Shift 6. Right, so get that up arrow there. That is going to tell Excel that you want to take an exponent or a power of the data. So we'll do that up arrow, which is Shift 6. And then I want to square it, so I'm just going to put a 2 here. And so again, a 2 is greater than 1, so our correction is a power greater than 1. So I'll hit enter, and we'll see here that we got a transform of 4, which is correct. 2 squared is 4. Right, and so we can now take this variable and we can drag it down. So just like we've done all our calculations and drag downs before, I'm going to hover over that bottom right hand corner, and I'm going to left click hold, and I'm going to drag it down. So notice when I do that, it's going to drag that formula down. So 2's become 4, 3's become 9, right? 3 squared is 9, 4 squared will be 16, so on and so forth. And we'll drag that all the way down, and we'll stop where the data stops. So this is why it's important that we go ahead and we sort our data beforehand, because we don't want to sort our formula or drag our formula over an empty cell because we didn't sort the data, right? And we're going to do one variable at a time, right? Because when you sort the other variable, right, it impacts the first variable. So we just want to make sure we do one variable at a time here. Okay, so we've transformed our satisfaction variable. We squared all of the values. Now let's go back and check and see how this transform performed. Did it correct our skew, or do we need to do a stronger transform? So I'm going to go back to my data analysis icon, get my descriptive statistics. I'll click OK. Okay, now I'm going to change that input. I want to change it now to column D for my transform satisfaction. Everything else is going to be the same here except for my output. And just to keep things consistent, I'm going to put this output right below the untransformed satisfaction variable. And then I'll click OK. I'll get my new descriptive statistics, and the first thing I want to look for is this skewness statistic right here. And essentially I want to know, is this skewness statistic falling within my range of normality. So again, our count is still 79, so we'll look at the row for 80. We get negative 0.39 for the skewness statistic, and if you remember, the skewness cutoffs in this case was plus or minus 0.41. So you'll note that negative 0.39 does fall within plus and minus 0.41, not by much, but it is in there, which tells us in this particular case that our distribution can be considered to be normally distributed. So we have corrected for the skew. It's not a perfect correction, but that's okay, within the range of what we would accept as a normal distribution. And so we don't need to go and do another transform and increase the power of the exponent for it. We can now continue to calculating our z-scores. Remember that z-scores require a normal distribution, which we have just ensured. So when we calculate these z-scores, we can be confident that we're going to get accurate z-scores. All right, so in order to calculate a z-score, we need the mean and standard deviation of the variable. Now we transform this variable, so therefore we need to make sure that we get the mean and standard deviation of the transformed variable. And of course we'll get this from our descriptive statistics. And then just remember, if we have population data, then we need to recalculate the standard deviation. If you have sample data, you don't need to recalculate the standard deviation. You can use the one that is in your descriptive statistics. Now we mentioned before, as far as our situation here, we're saying that we were a therapist and we had clients, and we're getting a measure of all of our clients. So therefore, this would be population data. We can measure each of our clients and get these values. It wouldn't be very difficult to do so. So this would be population data. So we will make sure that we go ahead and get a new standard deviation for the population before calculating our z-scores. So let's go ahead and do that. You'll remember that if we want to get the standard deviations for population data, then we're going to hit our equals. We'll click on that cell right next to our standard deviation and we'll click equals. We'll type in ST for standard, DEV for deviation, and P for population. We will open our parentheses and we're going to select our data. Now remember, this is the transform satisfaction variable. So we're going to make sure that we do column D here for the transformed satisfaction. Close out our parentheses and we'll hit enter. And we should get something very similar to what we had with the sample standard deviation, just a little bit smaller, and we do here. All right, so we're going to use this value of 13.07 in our z-score calculation. All right, so we're going to create a new column here for our z-scores. I'm going to call this one z underscore SAT for satisfaction. And we're going to look at our formula down here. So if we're looking at our directions, we'll see that our formula, so we just did our new column, we see that our formula is the cell that we want to turn into a z-score. Subtracting the mean, and again this would be the transformed mean in this case because we transformed our variable. If we didn't transform our variable, we'd use the raw mean. And we're going to divide by our new standard deviation for the transformed variable, and again adjust it for the fact that we have population data. And then once we get that, we'll drag it down just like we did the other transform. So I'll click on that very first cell under my new label. I'm going to hit equals here. You're going to notice in the directions that we need an open parentheses, which I'll go ahead and do. I'll go ahead and click on the transform satisfaction value. So don't do the original values, do the transformed values, because remember the transformed values are the ones that we're assuming are a normal distribution. And z-scores require a normal distribution. They assume a normal distribution. So don't do the original data that was negatively skewed. Make sure you're using the transform data that we can assume to be a normal distribution. Okay, so if I'm looking at my directions, I'm now going to subtract the mean. But again, I want to subtract the mean for the transformed variable. And here you don't want to click on the cell in your table. You want to go ahead and just type that over. So we'll just go to 2 decimal places. We're going to type in 28.80. That's going to be our transformed mean. We're then going to go ahead and divide by our population standard deviation that we calculated, again, for the transformed variable. So in this case, it's going to be 13.07, again, if we're rounding to 2 decimal places. Once I have that, I'll hit enter, and that is going to be my very first z-score. And so it looks like in this case, our transformed value of 4, it corresponds to a z-score of negative negative 1.90 again if we are rounding. All right, we want the z-scores for the rest of our clients, so I'm going to go and click on that first cell there with the z-score in it. Hover over that bottom right hand corner, left click and hold, just like we always do. We're going to drag down that formula, and again we're going to stop where the data stops. And I will release, and then there are all my z-scores for each of my clients. And you'll notice that some of the values are being repeated here, and that makes sense, right? Because the corresponding raw score are 4, so everyone who has a 4 is going to have a z-score of a negative 1.90. Okay, so we're almost done with our very first z-score. We're going to go down here, we're going to double check just really quick. We want to do our descriptives one more time now for our z-scores. And so if we don't have any obvious errors, now there always could be some other errors, but if we don't have any obvious errors, then the mean and the standard deviation of the z-score should be 0 and 1. So the mean should be 0, it should be perfectly balanced, and then the standard deviation should be close to a value of 1. Now in our case there will be some deviation from that because we rounded to 2 decimal places, but it should be very close to 0 and very close to a standard deviation of 1. So let's get our descriptive statistics one more time. So we'll go to data, data analysis, descriptive. We're going to change our column to column E now. And we're going to change our output to just below our transform satisfaction variable. We'll click OK. And we're just going to check those two things just really quick here. So it looks like our mean is very, very close to 0. It's a negative 0.00019. That is really close to 0. If we didn't do any rounding, it would be perfectly 0. And we're going to look at that standard deviation, and that standard deviation is also close to 1, just like we would suspect. Remember, in a normal distribution, it's centered at the mean of 0 in this case, and a standard deviation of 1. So remember, the center of the distribution in terms of z-scores is 0. And then the standard deviation is 1, is what we see here. So we are, at least in this case, looking like there's no obvious errors in our z-score calculation. So that looks good. Let's go ahead and go to our other variable, alcohol. We're going to do the same thing. We're going to walk through the same steps, right, and make sure that alcohol is normally distributed before we get our z-scores, which means we may need to transform them. Now remember, we have some empty cells here, at least one, if not more. We are going to go ahead and sort our column C here. And I'll do smallest to largest. And note that when we did that when we sorted alcohol, all the other columns sorted as well, just to make sure and maintain that integrity of each client or participant falling in the same row. So we did our sort. Let's scroll down. It looks like there were 2 empty cells. So that means when we create our transforms and our z-scores, we are going to stop where the data stops. Right? We're not going to continue past these 2 cells here. Okay, so now that we've sorted our data, let's go ahead and get our descriptive statistics. And we're going to do it on our original data for alcohol. So that means I need to change my column again for my input. We'll do column C. Change the output. And I'm just going to go ahead and put it right here next to my satisfaction variable. I'll click OK. And again, what I'm looking for here is that skewness statistic. And I want that skewness value to fall within the range of normality. And again, for it looks like a count of 77, so on our table we'll go to 80. We round up to 80 in this case. We always go to the row that it's closest to. That will minimize the error. And again, we're looking for a skewness statistic between plus and minus 0.41. So a value of 1.8 definitely falls outside of that range. Now it's in the opposite direction. Notice our skewness statistic is a positive value, so this is a positively skewed distribution. That means we need to do a transform. And if we look at our transform directions, we will see that if we have a positive skew, we're going to take our original values and we're going to use a power less than 1. So we'll start off with the square root here. That is an exponent or a power of 0.5. Certainly that's less than 1. And we'll see if that will correct our skewed distribution. Of course, if it doesn't, then we'll have to use a stronger transform. All right, so we're going to put our new label here. I'm going to put T. Again, just to remind me, this is going to be our transformed values. And now we're going to do it for alcohol. So I'm just going to put ALC, just enough for me to remember what that variable is. Again, to calculate that transform, we're going to hit equals. We're going to click on the cell of our original data. So make sure you're using the alcohol column here. So that'll be that first 0. Again, to take it to an exponent or a power, we're going to do Shift 6. That's going to give us this up arrow right here. And we want to type in a value less than 1. So we're going to type in a decimal here. 0.5 would be a square root. And I'll go ahead and hit enter. And you'll see there that we have a 0 value. That's our transformed value. And we're going to go ahead and drag that value down, again hovering over that bottom right hand corner, left click and holding. And then this is the part that's important, is we're going to stop where the data stops. Right? We're not going to drag this formula over these empty cells, because if we do that, then Excel is going to think that those are zeros. And they're not zeros in our data set. Right? And so if we drag over them, then we're going to impact our not only our transforms, but the Z-scores as well. So stop where the data stops. And so notice that this is working here. 100 square rooted should be 10, and we see that here as well. All right, and so it does look like our transform is working as it should. Now remember, once you get your transform, we do want to check and just make sure that the distribution can now be considered normal. So let's go ahead and get our descriptive statistics one more time. So data tab, data analysis, descriptives. We're going to change our column again. Now it's going to be column F. And we're going to put our output range just below our variable. And we will click OK. Let's take a look at that skewness statistic. It looks like it's now 0.21. If you remember, based on that skewness table, we wanted a value between plus and minus 0.41, again, because we had 77 observations. So again, rounding to the nearest sample size here, it would be 80. And so that definitely falls within our range of normality here. And so we consider this now to be normally distributed, and it is acceptable for calculating Z-scores now. Now remember, we do have population data here. So remember, we need to make sure that we change our standard deviation to a standard deviation for a population rather than a sample. So we'll hit our equals button. Then we will put in ST for standard, DEV for deviation, and don't forget that P for population. We'll open our parentheses here. We'll go to our transformed alcohol value. Remember, we want to use the transformed values, not the original values. In that case, it's column F, so I'll highlight column F. Close out my parentheses, hit enter, and there is my new standard deviation for the population. It's a value just slightly smaller than the sample standard deviation. So we'll use this 2.72 when calculating our Z-scores. Let's scroll back up to the top of our spreadsheet. Let's go and put our label for our Z-score. So I'm going to do Z underscore ALC for alcohol. Remember, down here in our directions, right, to get Z-scores, we need to create a new label, and then we'll use our formula, right, and drag that formula down. So here I'm going to hit equals. Now remember, the column of data that we're assuming to be normally distributed is the transformed alcohol column. So we're going to make sure that everything we do in this formula has to do with the transformed values, not the original values. All right, so looking at our formula, we're going to click on our cell. We will subtract the mean. And again, we want the mean of the transformed alcohol data. So in this case, it's going to be 3.39. We will close out our parentheses, and we're going to divide by the population standard deviation of 2.72. Once we have that, we'll hit enter. You'll notice in this case that our Z-score calculation is a negative 1.25. All right, so let's go ahead and drag that formula down. So bottom right hand corner, left click hold. We will drag down, and again we're going to stop where the data stops. We don't want to go beyond it, because if we do, then we will get calculations as if the values were 0. But if they're empty cells, then we don't know what the participant would have actually put. We don't want to drag down the formula and create an error. All right, so it looks like when the transformed value is a 10, the corresponding Z-score is 2.43. Now, if you remember, right, that values greater than 2 or less than -2 for a z-score is considered an extreme score. So in this case, this 2.43 would be extremely above average. Remember that values that are between 1 and 2 are considered above average. Values between 1 and -1 are considered to be average. And then values between -1 and -2 are considered to be below average. Any value less than -2 would be considered an extremely below average value for a z-score. So we don't have any extremely below average z-scores here. Our lowest z-score is -1.25, which again would be classified as below average. So again, just remember what those classifications are. Make sure you have those memorized when it comes to an exam or whenever you're looking at z-scores. All right, so there's our z-scores. We have z-scores for satisfaction. We have z-scores for alcohol. And if for some reason I wanted to compare the satisfaction to alcohol, I could do that as long as I convert them to z-scores first. Because now they're on the same metric, right, in terms of z-scores, in terms of standard values. And so now they're directly comparable to each other if I needed to make some decisions based on those two variables. All right, so that'll do it for z-scores. Make sure that you don't forget to take your spreadsheet, save it, and upload it to show that you have completed it, and you've got the practice that you need to move forward when we go to class. Thank you.